In this class, we're going to consider how you can solve quadratic equations which don't factorize using a numerical method called the quadratic formula. So if you've already done some quadratic equations, which hopefully you have done by this point, then you'll know that one way that we go about solving them is by factorizing. So let's say we've got this quadratic equation. We can factorize that into two brackets. So this is a trinomial. Factorize it into two brackets as a trinomial as x plus 5, x plus 3, and then we separate this off into two separate equations. So x plus 5 is 0, x plus 3 equals 0, and then we get our two solutions. But that whole method, which you probably have already tried at this point, only works if this can be factorized into two brackets, or it doesn't have to be a trinomial. It can factorize into one bracket, or it can be a difference of squares, so different types of factorizing, but they have to factorize. Whatever the format is, it has to factorize. So getting from here to here, and then subsequently to the solution, is all dependent upon whether this is factorizable. The examples I've got here cannot be factorized. So if it cannot be factorized, then what does that mean? What do we do? Sometimes it means that the equation doesn't have any solutions. And that's fine. That's one difference between a quadratic equation and like a normal linear equation. Linear equations have always got solutions. Sometimes quadratic equations don't have any solutions, but sometimes they do have solutions even if they don't factorize. So what we're going to look at in this class is how can we find those solutions even if we don't have the ability to factorize the expression. So remember that in general, a quadratic equation is of the form ax squared plus bx plus c, in other words, a quadratic expression, equal to 0. If we take an example, we'll park that for a minute, we're going to come back to that. If we take an example like x squared plus 4x minus 7 equals 0, we could try to factorize that into two brackets. It's not going to work because a 7 is a prime number. To make a 7, you would need a 7 and a 1. And there's no way to use a 7 and a 1 to make a 4. So this definitely doesn't factorize. We could solve it though by a method of completing the square. So if you're familiar with completing the square, which again you probably are by this point, then this is a little algebraic process which works by rewriting this in a different format. Completing the square on this guy would look like this. If you're not sure what I'm doing here, it doesn't really matter too much. This is just for illustration. But basically this is a little numerical, algebraic method that we use. And you would end up here with a minus 11, that would become an 11 like this on the other side of the equation. Taking the square root of both sides, you get x plus 2 equals plus or minus the square root of 11. So remember when you square root, you get a plus and a minus. And then we could just move the 2 to the other side. So plus or minus root 11 minus 2. So that gives us a solution, which to get as a decimal, we would just put into a calculator, taking both the plus and the minus, so actually giving us two solutions to give us solutions to that equation, even though we could not factorize it. We kind of did a form of factorizing, this completing the square method. But what we're going to do in this class, we're going to take that method and apply it to a general quadratic. If I was to go through that completing the square process on this general form here, it would be quite a lot of algebra, but I get to a certain point where I get my solutions which look a little like this, but they've got the a, b and c general values in them. And that form is called the quadratic formula. And it just basically means that to solve quadratic equations which don't factorize, we just need to know the a, b, and the c values, a, b, and c. So a here is 1, b is 7, and c is 5. So once you go through the completing the square for this, you're going to end up with x equals minus b plus or minus square root of b squared minus 4ac, all of that divided by 2a. It's a bit ugly. It is a bit ugly. When you see this the first time, it's a bit like, what is going on there? The square root is such that we need a plus and a minus, because when we're square rooting, just like in my example here, we need a plus or a minus. So when you work through these, it allows for two solutions, one with the positive, one with the negative. We'll see that in the examples we're going to work here. This basically means if you've got a quadratic equation which does not factorize, you just identify the a, b and the c values, plug them into this formula, and then it just becomes a numerical method to solve the equation. Quite often these will come out to be decimal solutions rather than whole number solutions, but you could get whole number solutions also. So let's take this method and apply it to this first one here. The first step is to identify your a, b and c values. So for this one, a is 1, b is 7, and c is 5. I would recommend writing those down. A lot of students just try and keep them in their head, but I think it's too easy then to make a mistake. So I would say physically write them down, or just write a, b and c above the values in the equation. We're just then going to take these and plug them into our equation. So x equals minus b, so that's minus 7, plus or minus the square root of b squared, so it's going to be 7 squared minus 4 times a, which is 1, times c, which is 5. So rather than writing in a multiplication sign there, I'm just going to use brackets to represent the multiplication. And all of that divided by 2 times a. 2 times a is 2 times 1, which is just 2. Okay, so you've just now basically got to carry this forward until you get a numerical solution. Just be really careful with your working. If these are calculator questions, which they normally are, you could theoretically at this point just put all of that in your calculator. That's okay, you can do that, but just be careful about the, especially about the negative. I wouldn't really recommend that. I would say take at least one more line of work in, probably 2 more lines of work in before you introduce the calculator. If you do want to use the calculator, just be ultra careful. So I'm just going to develop this a little first. So we're going to get 49, 7 squared minus 20, all of that over 2. Taking that a little further again, so we're going to get minus 7 plus or minus 49 minus 20 is 29, so we'll get root 29 over 2. All that we do at this point is then separate these out with one solution with the plus, one with the minus. So let me just take the minus out of there. So I'm going to write this as x equals that guy there. That's one solution. And the next solution, which I'll put underneath, would be the same thing, but with the negative. So x equals minus 7 minus root 29 over 2. And that would be our 2 solutions. You could leave them. Sometimes questions will ask you to leave them in this form. Sometimes it will ask you to then process that on a calculator and get a final decimal number. Either way is fine, just depends on the question type. I'm just going to leave that one at that point. But basically, just a quick recap, all we did there was identify our a, b and c values, so that was that step, plug them into the formula at that step, work through the numbers, and then basically separate them off at the end, one with the minus and one with the plus to get the 2 final solutions. It's never really any more difficult than that. Just be ultra careful with your numbers. I see a lot of numerical mistakes in these, particularly around like double negatives and things like that. Doing the same over here, identifying our a, b and c values. So a is 2, b is negative 3. Remember to look out for negatives in particular. You've got to keep the sign that goes with the term. And the c value is 1, so we're going to get x equals minus b, so it's minus 3, which is going to be 3, so be really careful with those. That's a common mistake to miss that double negative. Plus or minus the square root of b squared, so it's minus 3 squared. Make sure you use a little bracket for that. Remember, minus 3 squared, a negative squared will be positive 9. Minus 4 times a times c. Make sure your square root covers all of your terms. And divided by 2a, which is 2 times 2, which is 4. Okay, so just taking this forward again. So nothing much we can do with the 3, just leave that. 3 squared is 9 minus 4 times 2 times 1 is 8. So it's going to be like that. So the numbers look a little easier this time. So it's going to be 3 plus or minus the square root of 9 minus 8 is 1. Square root of 1 is 1. So we just get 1 over 4, and then 3 plus 1, so 3 plus 1 over 4, that's one solution. The other solution will be 3 minus 1 over 4, and those can obviously be processed manually because they're quite easy numbers. 3 plus 1 is 4, divided by 4 is 1, and 3 minus 1 is 2 divided by 4. 2 over 4 is 1 over 2. So in that case, we were able to process them manually and just get our final sort of solutions like that. This is the more common form though. You'll see a lot of solutions coming out looking like this rather than coming out looking like that. If you're going to get easier solutions like that, then generally those would be questions where you could factorize the original quadratic expression. So don't overthink these questions. They're generally fairly straightforward. Usually you get this on a formula sheet. If you don't have it on a formula sheet, you would need to memorize it, which is a little tricky. Even if you do get it on a formula sheet, try and memorize it, because it's very easy to make little mistakes like putting a plus here instead of a minus, or a plus here. So try to be at least familiar with the format. Once you are familiar with that and you do have access to it, just pull in your a, b, and c values from the equation into the formula, carefully work through the working. Try to take at least a couple of lines of working to get the numbers sorted out. If you can process them manually like this, great. If not, just get to this point and either leave them, or more commonly probably is to then put that in a calculator. And the question would probably ask you for a solution written to 1 decimal place or 2 decimal places, or some level of accuracy. Usually when you have to use the quadratic formula, the solutions will come out to be decimals, but it could be a mix. It could be decimal. Some questions could be whole numbers as well. So quadratic formula questions, fairly straightforward. Just gain a bit of experience by working some practice questions, but probably not as important as learning to solve these by factorizing. In the long run, solving them by factorizing will be a far more powerful skill to have. But these are very common questions, so it's likely that if you have quadratic equations in your course, then you will see a question or two like this on your tests and on your exams. So worth spending a bit of time getting comfortable with this technique.